section 6.1, relations and functions. This first part should be a little bit of a review for you because we've been doing it for quite some time. It's about ordered pairs. Basically, you know this is a pair of numbers that gives coordinates of a point on a coordinate plane. And we always write it as x, y. So we know how this works already. A couple of things that we haven't really mentioned is about what we actually also can call these things. We could call them inputs and outputs. Inputs is basically the x value, and output is basically the y value. So this is something that's interchangeable in mathematics. If I say the x value, I'm meaning the x value. If I say the input value, I'm also meaning the x value. Another thing that we also would call, especially in science, and you may see this later on, is what we call the independent variable. So x, input, and independent variable all mean the same thing. There's this and then at the same time, y, output, and dependent variable all mean the same thing. Now, the next big piece of this is what we call relations. It's pairs of inputs and outputs. So I've kind of given you different examples of types of relations here. So I've given you a list of ordered pairs. This list of ordered pairs is a relation. This is something that we call a mapping diagram. We're going to do a little bit more here, but if you notice that, to be more specific, this line represents my inputs, this represents my outputs, and notice that this inputs, outputs, x and y's, is just another way of denoting these ordered pairs. You've seen tables before. These ordered pairs are literally the same thing that are in this table. This is a relationship, and then these same ordered pairs have I plotted in a graph. This is also a relationship. So this is 4 possible ways that you may see a relationship in mathematics: ordered pairs, mapping diagram, or a table, or a graph. And you've seen most of this before. All right, lastly is the big thing I really am more interested in, and is the definition of a function. Functions are very important for you to understand, especially when you go into Math 1. It's a relationship, so it's the relations that pair each input with only one output. So it is a set of ordered pairs. It's all of this, but there's a specific definition to it. It says that each input is with only one output. I like to say it this way: no x value will repeat. No x values repeats. That should be erased. No x value will, wow, bad grammar, Mr. Lewis, will repeat. No x value will repeat. And I'll show you what I mean about that in just a few moments. So let's just go ahead and start looking at a few things. So practice A, this is very simple. This shouldn't be that complicated for you to figure out. It says describe the pattern in the mapping diagram. Notice that I have an input and then an output. And it says copy and complete the diagram. I'm not really worried about copying it over into another thing, but this is just basically, we're just going to describe it. So notice how it's going 1 to 3, 2 to 6, 3 to 9. Well, if we kind of continue that pattern, you probably can see 3, 6, 9. The next one will be 12 because it looks like it's counting by threes, followed by 15, followed by 18. Pretty simple standard stuff right there, just completing that pattern. And then it's the same thing on this one. I have -2, 0, 2. If you notice, what I happen to have here is I'm adding 2 to each one. -2 plus 2 is 0, plus 2 is 2, so the next one would be 4, 6, and 8. Pretty standard, nothing complicated on completing this very pattern. This next one's also a little bit more simplistic than I wanted to do, so I've given you some more examples here in a moment. But it's telling me to list the ordered pairs showed in the mapping diagram. So recall that I said a while ago, inputs are your x values and output is your y value. So this 0 goes with this 1. So my ordered pair would be 0, 1. This would be 2 and 2. This x goes with that y. And then 6 to 4. That one's pretty straightforward again. And this one beside it is the same concept because it goes right straight across. It's not that complicated. So this would be 1, 9, 4, 4, 7, -1, and 10, -6. Pretty easy, nothing really complicated with this stuff. Now, the next piece, it says draw a mapping diagram to the set of ordered pairs. So in this particular one, we're basically going to be creating this mapping diagram. And so how would we do that? Well, what we want to do is we need to look at the x values first. So let's look at all of my x's. I have an x, and this x. So what I would do is I'm going to write 1, 3, 6, and 10 down. And these are my input values because my x values are my inputs. And now I'm going to write my y's. I have a 2, a 5, a 9, a 12. So 2, 5, 9, and 12. And I'm going to put that to the side. This would be my output. And basically, I'm going to draw a line to each one. So 1 goes to 2. That's easy. 3 goes to 5. 6 goes to 9. 10 goes to 12. All right. That one's pretty straightforward. Nothing really complicated on that one. Let's look at the next one. Again, we're going to list all our input values first. So input would be -2, 0, 5, and 4. All right, so we've got that. My outputs would be 7, 5, 8, and 9. Well, there's one thing I don't like about this. Notice that these right here are not in order, so I'm going to rewrite this and put them in order because that's a better way of doing a mapping diagram, is making sure that the numbers are in order. So I do have my 7, I have my 5, 8, and 9. So I can kind of close that up. Now let's match our stuff. -2 goes to 7, so -2 goes to 7. 0 goes to 5, 5 goes to 8, and 4 goes to 9. All right, so this one looks a little bit different because of the way the numbers cross, but 0 goes to 5, and that's my order pair, 0, 5. Nothing too bad on that one. All right, let's go on to 7. Table shows the number of tickets purchased and the total cost. Use the table to draw a mapping diagram. All right, so let's do that. We have a table. We know our tickets and our total cost. So this kind of goes back to what goes where. Well, if you can kind of think about it, more than likely our tickets are going to be our X variable and this is going to be our Y. Here's the reason. This would be my input. This is how many tickets I'm going to buy. The number of tickets I buy changes the number of cost. Basically, you understand this by saying one ticket is $14, but if I buy 2 tickets, it increases the price to $24. So this would be my X and this would be my Y. This is my input, my output. This is my independent, my dependent. Now it's just a matter of doing exactly what I did a while ago for this. 1, 2, 3, 4 for my inputs. I'm going to write I because I'm getting lazy now. And I'm going to do 14, 24, 30, and 32 for my outputs. And now it's just a matter of connecting the points together. All right, pretty straightforward. Now this next one, it says, is the relation a function? Explain. All right, so now we're getting into the question that I'm really more interested in, is the concept of a function. Recall what I said earlier about function. No x values will repeat. So if we were to look at this, I have 1, 2, 3, and 4. Do they repeat in any form or fashion? No, not in this particular case, they don't. And also we can look at the other part of the definition. It says that each input is with only one output. So each input only has one output. So there's only one line coming from this input, from each one. So this is indeed a function because of this definition. Each input has only one output. So yes. Describe the pattern. How does the cost per ticket change as you buy more tickets? All right. So let's see what happens. When we buy 1 ticket, it's $14. But when we buy 2 tickets, it was a plus 10. We added 10 more dollars. When we added a 3rd ticket, it was actually plus $6. And then when we added a 4th ticket, it was actually plus $2. So what is the pattern changing on this? Well, this is interesting. So we went 10, 6 to 2. All right. Let's walk this one through. Sorry about pausing the video there. I started looking at this problem and I actually started noticing something didn't seem right, so I had to go check the answer key to see what was going on. This particular problem is not a good problem, so we're actually going to scratch this one out. The biggest thing I wanted you to know, and if you're more curious about what was happening in this problem, you can come ask me. But biggest thing I want you to know that this is indeed a function, and if we were to look at the pattern, the cost of the ticket ultimately is going down. The more tickets I buy, the cheaper the ticket cost. But again, we're not going to go into all these other questions because it gets into some strange territory. Let's get into some more important things, though, is I want to talk about this last piece, and it's the concept of, is it a function? All right, so recall my basic definitions it's relations that pair each input with only one output. Basically, no x values will repeat. So if we were to look at it, let's just look at right at my x values right now. I have a 2, a -3, a 2, and an 8. Automatically stop. This is not a function because the x value here repeats. All right, let's look at the next one. 2, 3, 8, and 9. My x values, did any repeat? No, so this is a function. Let's look at number 3. Now, this gets confusing, so the easiest thing for you to do if you don't understand what you're seeing is go ahead and write this as an ordered pair. So this one would go 2 and 1. It also says 2 and 2, 4 and 3, 5 and 2, and 6 and 3. So I've listed them all out as ordered pairs. Now let's look at our x values. 2, 2, 4, 5, and 6. Stop. Notice that these x values repeat. So the answer to this is no, it is not a function. Let's look at this one. Do the same thing. We have 2 and 1. We have 4 and 1, 5 and 1, and 6 and 2. So let's look at our x values. 2, 4, 5, 6. Did any repeat? No, it didn't. So guess what? Yes, this is a function. All right, let's look at the last two here, and we'll be done. So you might be able to see it automatically here if you're looking at the graph, but let's just pay attention. And if we were looking at the ordered pairs, so this ordered pair right here would be 1 and 1. This would be 2 and 1. This would be 3 and 2. And this would be 4 and 3. If we were to look at the ordered pairs. Now let's look at each of the x values. I have 1, 2, 3, and 4. Did any x values repeat? No, it didn't. So yes, this is a function. No x values repeated. Let's look at this next one. I have 1 and 1. This would be 2 and 2. This would be 3 and 1. This would be 3 and 3. This would be 4 and 4. And this would be 4 and 6. So let's look at it. We're going to look at my x values. 1, 2, 3, 3, 4, 4. Did I have any x values to repeat? Absolutely. Therefore, because we have x values repeating, this is not a function. No, it's not a function. So that's basically it. Sorry for the pause in the video. The biggest takeaway is understanding what a function is, what it's not. Remember, if x values repeat, it is not a function. That's the big definition from this video. And if you got any questions, you know how to find me, and I'll see you in the next one. Bye-bye.